Hello all. In this video, we'll be discussing about lead code problem number 28, that is find the index of the first occurrence in a string. So here you are given two strings, needle and haystack, and you have to return the index of the first occurrence of needle in haystack. Otherwise, you have to return -1 if it is not found. So now let's directly jump to the example. So here you are given a string this and a pattern ABC. So as you can see, the pattern is occurring in the text from fourth index. So that's why the output is 4. So now let's solve it with the naive approach. The naive approach can be that, say for example, this is the text of length of length n, and this is the pattern of length m. So now what you have to do is you have to match it index by index. Okay, since this is not matching, we can just shift the pattern by one ahead and then we can start matching again. Since again it is not matching, we can just increment it by one again. Then A is matching, B is matching, then A is matching, B is matching, C is not matching again. Again we can shift the pattern ahead by one. Then we can match it. Here it is again not matching. For this case, again incrementing A, B, C. So this is matched. So iteration number 0, 1, 2, 3 and 4. So that is why for this we can directly return 4 as output. So now since this is the naive approach, the overall time complexity for this comes out to be n into m, means length of the text into length of pattern, since at each and every step we are matching the pattern, and in worst case the matching will be done for m length. So that is why the time complexity comes out to be n into m, and space complexity for this case is O of 1. So now in terms of time complexity, if we want to go for further efficient approaches, then there are multiple existing. However, for this video, I'll be discussing about the KMP algorithmic approach. This is a famous algorithm that works on the principle of finding the longest border. So now first of all, let's understand what is a border. So here for the pattern, we'll be calculating the longest border for each and every substring of it. So now let's understand this. So before proceeding, again, what is proper prefix? All the prefixes of a string except itself are proper prefixes. Similarly, for proper suffix, I can say that all the suffixes of the string except itself, that is a proper suffix. So say here for an example, A is the string, then except A, the proper prefix and suffix is null, right? So this is an empty string. So that's why there is no border in this case. However, for string AB, we can say that proper prefix is A, whereas proper suffix is B. Again, there is nothing matching in this case, so there is no border for this also. Now for string ABA, the proper prefix are A and AB, whereas proper suffixes are A and BA. So in this we can see that A and A is matching, so that's why the border for this is A. For the next case, the proper prefixes are A, AB and ABA. Similarly, proper suffixes B, AB and BAB. So out of this, we can see that AB and AB are matching, so that's why the border for this is AB. Now for this string, these are the proper prefixes and these are the proper suffixes. However, nothing is matching, so there will be no border for this. So I hope the concept of the border is clear. Now let's see its utility. Before proceeding for that, let's see how it is calculated in this using algorithm. So we'll be calculating the longest border of the pattern using this. First of all, we'll be initializing two variables. One is previous, that will be pointing to the 0th index, and a variable I that will be traversing, with the help of it we'll be traversing further. Till I is less than n, we'll be traversing each and every element and we'll be trying to find the longest border. How? By comparing I with previous. Okay. So now, is previous indexed character equal to ith index character? No. Here in this case, since it is not equal and here previous is 0, so that's why longest border for this case will be 0 only. Okay. So for this will be 0 and I will be incremented further. Now again, if I'll be matching here this equal to this, yes, A is equal to A. So what we will be doing is we'll be incrementing the previous by 1 since we have found a border, and then longest border, what will be the value here, will be equal to previous, since previous is 1, right? Index is 1. So I'll be saying that it exists at index 1. So that's why we have updated the index as 1, and then we'll be incrementing I. Again, B is equal to B, that is ith index and previous index characters both are same. So that's why again we'll be incrementing previous by 1, and then longest border will be now second index. So that's why it will be second index, and then we'll be incrementing I. But since now previous and C is not equal as well as previous is not equal to 0 also, so this will be the case. This will be how previous will be updated. What we'll be doing, previous is equal to longest border of previous minus 1. So previous is here, longest border of previous minus 1 is 0. So that's why we'll be directly keeping a longest border of 0 here. So the final output of this complete algorithm will be A, B, A, B, C. The borders will be 0, 0, 1, 2 and 0. What it is telling, for B the longest border is here. For A it is this. Okay. So now let's see how using this we actually match the final pattern with the text in KNP algorithm. So this is the short algorithm that we'll be following. So here if the text and pattern will be matching, we'll be incrementing both by 1, and if all the characters of the pattern matches with text, then we'll be returning this haystack idx minus m. Otherwise, if it is not matching and pattern is at the start only, we'll be incrementing the text pointer by 1. Otherwise, we'll be updating the pattern to the longest border to needle index minus 1. Okay. So now let's proceed further with each of the pointers. Say this is the haystack idx and this is the needle stack. In short, this is the text pointer and this is the pattern pointer. Right? Since this is matching, we'll be incrementing both by 1. Again, this is incremented. This is also matching, incremented. Now here you can see that A is not matching with C. Right? Here the pattern pointer is not equal to 0. So that's why what we'll be doing is needle idx is equal to longest border of needle x minus 1. So we'll be calculating the taking the longest border of this, that is the index 2. So here we'll be keeping A, B, A, B and C. This is second index. This is 2, right? So basically it has told that us that AB is still matching. Directly proceed to the matching of second index character. So here again we'll start matching. Now A is matching, B is matching. Again there is a mismatch between A and C. So again what it will be telling, since needle index is not equal to 0, we have to go to the longest border of needle index minus 1. So basically it is 2. Again we'll be keeping here second index. So this means A and B has already matched. Now we'll be starting matching towards second index. So A is matching, B is matching, and here C is also matching. So now since both have matched here, so here needle x equal to m. Then yes, the complete pattern has matched. So that's why now we'll be returning haystack idx. So here it is 0, 1, 2, 3, 4, 5, 6, 7, 8. 8, and for pattern it is 0, 1, 2, 3, 4. So basically 8 minus 4 will be returned, that is 4 is the output. So for this, the time complexity for this algorithm is, since we have matched it in one iteration only, so it will be equal to length of the text, that is n. However, since we are storing the longest border in extra space, so the space complexity for this algorithm will be O of m. So now let's go for the code. So as per the steps here, first of all, we have tried to find the longest border. Here we have taken the longest border. Previous is initialized to 0 and I is initialized to 1. Then if it matches, I is matching to previous, then increment previous, update longest border and increment I as well. Otherwise, if it is not matching and previous is 0, put longest border to 0 and increment I. Sorry. Otherwise, if previous is not 0, then you have to update the longest border to the previous minus 1th indexed value. So in this way, you will be able to calculate the longest border. Now, after that, pattern matching will start with 2 pointers. So you have taken 2 pointers here. Till pointer is less than equal to n, till the complete length of the text is traversed. Now, if they are matching, then increment both the pointers by 1, and if the complete pattern has matched, then return pointer minus n as value. Otherwise, if they are not matching, then again the same case. If the pointer is 0, then increment haystack pointer, that is text pointer, by 1. Otherwise, if it is not 0, then update it along with the longest border value. Update it according to the longest border value of the pattern. So once we are done with this, then in between the answer will be returned if the patterns matches. Otherwise, if no pattern is found, then the algorithm will terminate with returning -1. Also, we have tackled the edge case of if the length of text is less than length of pattern, then we have to return -1 in that case also. So that was handled as a separate case. So that's all from my side. Thanks for watching. Have a nice day.